Welcome to Session F of the Quantum Industry Day in Switzerland 2021. So my name is Michele, and I'm happy to guide you through our session on entrepreneurship and quantum technologies today. So in this session, we hope that we'll be able to inspire you, the next generation of entrepreneurs, and to potentially to motivate you to go for a big jump, so for the big jump into the world of entrepreneurship and quantum technologies. So here we want to give you first an overview over the entrepreneurial landscape, and then share testimonials with you for the path from a researcher to an entrepreneur, and then also to share with you the view from the investor side. So basically to shed light on what triggers investments in quantum technologies. For this, I'm very happy to welcome today's speakers, Francesco Kienzle, Mathieu Munsch, and Olivier Tonneau. So Francesco is working as an advisor for the European Research and Innovation Program, so now Horizon Europe, since 2014. And as an advisor for future and emerging technologies, so he has seen, for example, the birth of the European flagship program in quantum technologies. Mathieu is co-founder and CEO of Qnami. So Mathieu holds a PhD from the University Grenoble-Alpes, and he has worked as a scientist at the CEA and the University of Basel. So where he worked on the development of new sources of quantum light. And in 2017, he founded Qnami with the goal to become a leader in the quantum sensor market. And here he is also very actively involved in the creation of a European quantum ecosystem. Olivier is founder and partner of Quantonation, so an investor dedicated to deep physics startups with the focus on emerging and disruptive fields of quantum technology. And beyond this, Olivier is board member in several quantum startups, such as, for example, Qnami, but also CATS or CryptoNext Security. So following our talks in this session, we want to also continue afterwards with the Q&A session. And so this Q&A session organized as an open panel discussion. So here, this discussion will very much live thanks to your active participation and thanks to your questions. So we are very happy to address your questions in depth. So both questions directed directly to the talks. So please also in this case, feel free to directly address your question directly to one of our speakers. But also, of course, more general questions, which will allow our speakers to share their experiences in the entrepreneurial landscape. Yes, please don't hesitate to ask questions also already during the talks. And we'll then, so please use the Zoom Q&A feature to submit your questions, and we'll then pick up your questions in the subsequent Q&A and are happy to discuss them in detail. So without further ado, I'm very happy to welcome Francesco, and I'm very much looking forward to his introduction of the support system for startups in Switzerland. Francesco, please, the stage is yours.
Thank you very much, Michele. You should hear me now. I will share my slide. And thank you very much for having me. So you should see my slide now. So it's a pleasure to share the virtual stage with Mathieu, which I have known now for some time. I will, and then with Olivier, which is a more recent contact, but it's a pleasure to have both here today. I will, in the first 10 minutes, I will give you an overview on what's here for companies or future companies in Switzerland, and what kind of support you can get from the Swiss ecosystem. I want there is one message you have to keep in mind out of the presentation is actually there is quite some support. We have a lot of support in Switzerland. It's more the question which kind of, where you should go and in which case. Good. So when it comes to companies in Switzerland, so you have basically three main actors. There is one big actor, which is Innoswiss, which is the major agency in Switzerland in charge of making technology transfer from the research lab to industry or to support innovation in industrial or SMEs setup. So the first big player in Switzerland is Innoswiss, and this is the channel through which most of the Swiss companies and the Swiss startups go through. There is nonetheless a second agency, which is not, the focus is not innovation per se, but it's more basic research, and this is the Swiss National Science Foundation. Nonetheless, they have one specific program I will shortly talk about, which is bridging between the research in the lab to Innoswiss. Actually, it's a joint program between the Swiss National Science Foundation and Innoswiss. Finally, I will introduce, say a few words on Horizon Europe. So this is the framework program for research and innovation, which also has some programs for startups. Not everything is accessible yet, but it's good that you know that there is this possibility. Part of it is closed at the moment for the Swiss entities, but it hopefully will be open again in the future. So let's start right away with Innoswiss. Innoswiss has actually two elements. The first one is one part of the activities are really dedicated to the creation of companies and the growth of these companies. So this is the Innoswiss startup program, which is the bulk of the support you can get in Switzerland. I will nonetheless spend a few words on the second activity of Innoswiss, and this is the internationalization program, because there, since quantum is very international, there are some programs in there that might be of sort of interest to young companies. So the startup program from Innoswiss. So the startup program from Innoswiss has basically two packages. The first package concerns really the startup per se, and is based on one key element, and these are people which have already gone through the process of building up a company, or people which are in areas, so which are on the private sectors in areas supported by Innoswiss. So this program is based heavily on coaching, startup coaching, and these coaches are, per definition, are selected and come from the private sector. So those are people which are in the ecosystem, which are in the verticals you want to address, and they know what you're talking about, and they are paid to help you enter these either the verticals or help you through the journey, through IPR, legal issues, and this kind of stuff. Besides the startup coach program, there is the second program is really a rich set of startup training courses, which helps you speed up your journey from a lab possibly through an entrepreneur. And they have courses on different aspects of this entrepreneurship journey. So this is really, these two elements are the core of the elements. As a Swiss-based startup, it's actually most of the time you will not, the drive will not come from the domestic market, but will most probably come from markets outside Switzerland. Switzerland is quite small. And we will address markets outside Switzerland. And for that, Innoswiss wants to expose you very rapidly to internationalization. And so international programs are made there to, as soon as you have some elements of your company, then they will take you and will bring you outside Switzerland in those countries where your products could be of interest for with interesting markets. Could be US, Asia, and so forth and so on. So this is the second part. Also there, they will support you in attending trade fairs through the globe. So coaching and courses on one side and internationalization are the bulk of the support to get from Euresearch. Besides the startup program, there is another program, which is the international program from Euresearch. This is not specifically dedicated for startups, but there are a couple of elements you should consider because they could help fund you and establish collaboration with other companies in Europe or beyond Europe and other research institutions outside Switzerland. The first one is the Eureka program, where you have Swiss universities or companies are collaborating with at least one entity in one of the 40 Eureka countries. And this is at any time, so you can submit at any time for proposal there. Another program is the Eurostars program, where also there products and services can be developed together with companies or with a research team outside Switzerland. Then there are another program or bilateral program. So Euresearch is establishing regularly bilateral programs with other countries across Europe, but also beyond Europe. Currently, there are programs foreseen with Sweden, South Korea, Canada, and Brazil. It's good to have a look regularly on these bilateral programs, because sometimes you might have countries which are of interest for you, either because you want to sell products in there or because they have some skills which might be of interest for your company. And finally, one other entity is the Enterprise Europe Network, which is also part of Euresearch. And this is a global network, primarily Europe, but not only Europe. Again, it goes in the US, it goes to South Korea, it goes to Israel. So it's a very broad network where you can leverage either to advertise the products and services you're offering, or also they are doing a lot of matchmaking events. And for example, the matchmaking event we are organizing tomorrow in the frame of the Quantum Industry Day is supported by Enterprise Europe Network. Yeah, good. So the startup program and the international program are two elements from the Euresearch program. I will spend one slide on the Swiss National Science Fund, because also there, Swiss National Science Fund is primarily interested in basic research, not much on the application or the business that comes out of that. Nonetheless, they have established a program together with Euresearch, which is called Bridge. Bridge has two components. So, and this is actually a good program if you're still in the lab and not yet ready to go to the market, but you think you have a technology, you have an idea that might be relevant for a product or a service. Bridge has the first program is a proof of concept called proof of concept. So these are 130,000 Swiss francs that you can ask for to make the first steps toward a possible product or a possible service. They have a second program, which is called the Bridge Discovery Program, which is larger. You can submit with one entity alone, or you can submit with up to two other partners. So you can build a consortium of up to 3 persons. And there it's longer, it goes up to 4 years. And each partner gets up to 840,000 Swiss francs for their activities. So Bridge Proof of Concept and Bridge Discoveries are for those people which are still in the lab and maturing technologies in the first step toward product and services. So this is for the national funding programs. There are nonetheless further programs, and these are the European programs. Currently, Swiss is having some kind of special status, so it's a so-called third country not associated with Europe, but nonetheless, I want to spend a few words on that program. Europe has created one program, which is called the European Innovation Council, so which is similar to the European Research Council, but this EIC has been built for innovation. It has on one side the EIC Accelerator, which is very much for companies, for startups. Unfortunately, this program is currently not accessible to the Swiss. So let's hope we get associated soon and we can access again that program. Nonetheless, the EIC has another program, which is called the EIC Pathfinder and the EIC Transition, which you might have a look if you're interested, because these are disruptive technology on a very early phase. So this is not mature to go to the market yet, but there as a Swiss, you can participate in a consortium. You bring your own funding and you will receive the funding from the Swiss State Secretariat. So have a look there if there is something for you. And beside the European Innovation Council, which is really designed for innovation, then there are the so-called classical collaborative projects, which are bigger consortia, but nonetheless, there are also their calls which are accessible to the Swiss. Not everything is accessible. We have heard this morning that there are some limitations, in particular in the field of quantum technologies, but there are activities in the field of spintronics, there are in the fields of photonics, and some of the quantum technology topics are open to the Swiss. So there are not many, but a few of them are open to the Swiss. So it's worth having a look. So these are the three programs: InnoSwiss, the SNSF, and the Horizon Europe. Each come with their own support agency. So the InnoSwiss and the SNSF, they do support you if you have questions. So don't hesitate to contact them. While for Horizon Europe, this is my organization, so Euresearch. You can approach us if you have any question, and we are happy to help you to find a good grant or to orient you in what are the current facilities in that program. Here on that slide, I give you the website where you can access each of the programs. And with that, I'm done. There is actually much more than that. In Switzerland, it's a very federal system where you, and at the cantonal level, you have a lot of support. Here, for example, in Zurich at the Techno Park, you get also special equipment and special support. I will not go in all the details. Contact one of the two organizations. At Euresearch, we have company advisor, which will be very happy to help you or guide you in these huge opportunities that you have in the desk. With that, I'm done, and I hand over back to you.
Thank you very much, Francesco. Thank you very much for this very nice overview over the possibilities, especially in Switzerland. So yes, thank you. So with this, let's jump directly on to our next talk of today's session. So I would very much like to welcome Mathieu, and I'm very curious to hear about your perspective on how to build a company. Mathieu, please, the stage is yours.
Thank you very much. So yeah, I've been asked to tell a bit about the story of Qnami as an example of how it can work. By all means, this is just one example, one small use case. What I learned is that every single company is going to be very different. So I'm going to share a bit of our history, but you'll have to build your own if you're interested in starting up something for yourselves. So I'm Mathieu. I'm one of the co-founder, the CEO of Qnami, and I thought of introducing you who is Qnami first, so that you know who you're talking with, and then share a few of the learnings that we had on the way up to here. So Qnami is based in close to Basel. We're a spin-off of the University of Basel, founded in 2017. Our headquarters is still here. We're now planning on opening new offices in Stuttgart. It's a team of about 15 people. As you can see, still very focused on the science and the technology. A lot of us with PhD and quantum experience, but also rounded up now with executives and experience in sales and marketing. And as Michele introduced you in the beginning, our vision is to be one of these important players as quantum technology develops, and in particular quantum sensing. What we're kind of looking at is you all know, we all see a massive surge of data, right? It's now billions of videos exchanged every day. By 2030, it's believed that 20% of the world's electricity consumption will be due to ICT. That's, to put a number, this is about 1,000 nuclear power plants working just for that. So it's 200 kilometers away from you, wherever you are in the world. And we know that the curve is not reaching an inflection point there. It's only growing. And on the other side, we have the flip side is that it's taking a toll on the environment. So we're all looking right now for solutions that would allow to keep going with that level of performance and exchanging this data, which is transforming a wide range of industries, but also take more care of our environment. So this is the problem of a full industry, and the good news is that there are ideas how to possibly change that in the future. In this context, in the context of that conference, I'm sure quantum computing will appear to everyone here as one of this possibility. It offers tremendous amount of calculation for maybe a fraction of the cost, with lots of questions still related to that. And another is called spintronics. This is how you can engineer memories using the magnetic properties of materials. Now, when it comes to Qnami, what we have understood and realized is that for those type of new technology, they exist in the lab, but when you want to transfer them to the industry, you're missing a number of tools, and in particular, some which will allow you to perform diagnostics, quality control of chips on these type of technologies. So when you think of the potential market for those type of companies working in these fields, they're pretty much now stuck at niche markets or lab markets. But when you want to think of broader scale and the full impact, which means global and green impact, you have to really take it down further. So what we want is that with our tools, we enable scientists and engineers to explore new ideas, but also when they find those ideas, they can try and test their designs and reduce their error rates so that they slowly go towards a full industrialization of these new technologies. And the way we do that is with a new technology based on quantum sensing, which allows to get these very intimate details on new chips. The trick is that we measure magnetic fields, which carries a lot of different properties that I'm not going to talk about. But this, combining these measurements with the scale at which we can do the types of measurements, atomic scale, extremely high resolution, is our unique selling proposition. And kind of the proof that this idea is meeting a demand is the market traction that we have. You can see here a list of high profile early adopters that we're happy to have working with us. Amongst them is the Nobel laureate Albert Fert from Paris. He's the founder of the spintronics field and running a lab in Paris between CNRS and Thales. But as you can also see, there is the Fraunhofer Institute showing and highlighting this interest from the industry. Now, how did we go from a lab concept to there? Here are a few key points in time for us. As you can see, the very idea of the technology or the measurement principle dates back more than 15 years. And it's about 10 years now that the first proof of concept measurement have happened. So in your view, it might be a very long time. In my view, it's also a very long time. From a technology perspective, it's actually quite astonishing that only 10 years later, after the first proof of concept of such a complex technology, you can already have a product which sells in the market. Yet it shows that there is a certain time to mature the technology. And it's only in 2017 that we created the startup Qnami that you see today. In 2019, we were lucky enough to convince our first investors to join the journey. Amongst them is Quantonation and Olivier in particular, who led that first round, and will speak about their perspective on that. And last year, we launched the first product, this microscope, and this year concluded another Series A, which was now focused on growing this activity and actually diversifying a bit our portfolio. Now, I wanted to share a few things when it comes to creating a quantum product. I can think of three very important aspects that we had to deal with. One of them is scalability. When you move from the prototype to something that you want to sell, the scalability and the fact that you can reproducibly obtain the results that you have measured once quickly becomes an important part of the activity. And that was in our case very pronounced, in particular because we have a consumable element in that microscope. So the scaling of that small component became quite quickly an important thing to tackle. The second is that the proof of concept is a great instrument that shows the capabilities of a technology, but it might not well represent what will be the needs of the customer, the needs of the market later. So when we thought about designing a full microscope going beyond the proof of principle, it really had to be customer driven. In a sense, a lot of the features that are necessary for our users today were not even considered at all at the time of the first prototype. And that was serious engineering that we had to take into account in order to meet the market. And the last thing I think I wanted to point out here is because in our specific case, in the quantum industry, we're dealing with a technology that can be extremely complex. It's not the only place, but it's one of those places where the technology can be extremely complex, and you want, to a large degree, that this complexity remains hidden, that your customers don't need to understand all the details of the quantum technology to be able to operate your systems. That's easy to say. This is harder to implement, in particular at this point in time where we're already selling products to the market, and there is a quantum hype that everyone wants to understand how quantum works. We have to debug a bit here that you don't need to understand to operate the products. We have to do a bit of education that the technology can already be available, even if you don't understand what quantum technology is, and actually you might never want to be able to understand that. That's where I'm going to leave it for describing the quantum, the products, because this then diverges into many different directions depending on the product. But what I wanted to spend the last 5 minutes on is just a few main things that we learn on a few different topics. One of them is partnership. We found absolutely key to be able to leverage expertise outside our own organization. First of all, because it's absolutely not necessary to do everything yourself. It's more complicated, and in most of the cases more expensive than if you can find the right partner. It makes you stronger, and it makes you improve your costs. Now, the difficulty lies into how you can create value for two partners, and in particular when those two partners might be very different, either in goals or in sizes, as is often the case when you create a startup, right? You will want a certain piece of equipment from a manufacturer that is maybe a 1 billion company. So how do you have them care about what you do? How can you create value for yourself and for themselves as well, which is the key thing that you should be thinking when you secure a partnership. There is no single answer to that, but there are a few things that I think are really important to keep in mind when you think of creating your company. One of them is to plan ahead. time pressure is always going to play against you, in particular when you play with stronger player. The second is to find somewhere in this company, someone, a person, which we call it a champion, who we call a champion, to really support this idea of the alliance. Someone that really sees the value for himself and for the company and can be your proxy to that company. And then, of course, make sure that if this person has no decision power, you can also have access to the people with the decision power. Otherwise, you might end in a dead end. So I think those are really important, and they're to a certain extent common good sense. The one thing which I will mention is, like, once you have your partnership kind of settled and planned, you have alignments on the final goals between the different parties. Don't forget to monitor how this partnership is evolving. As for lots of stuff in a startup, the devil is in the implementation. Like, having ideas is easy, making them happen is more difficult. The second unavoidable topic is funding. Here, just throwing a few ideas, and I'm happy to answer more specific questions if you have. The first one is delayed dilutive rounds as much as possible. First, because it's a great experience. You're going to be in this garage mode for a while, and it really brings something to the cohesion of the team. And later you'll like it because of more financial reasons, like dilution of your own equity, etc. The second thing is to consider what you really want to achieve as a company in terms of speed, in terms of scale, in terms of exit, or a company that you want to own for a longer time, because from the answer to these questions depend the type of funding that you should be looking for. As one example, if you are planning on a business that really takes time to build and can be built with customers here and a product that needs to be integrated and evolve for a decade before understanding what is the market, maybe talking with the VC is going to be hard because you cannot really talk about an exit. You cannot talk about what's the technology going to look like, what's the market going to look like later. But it's still a perfectly viable business that can feed 10 or 20 or even 30 or more people in the company. The second is grant funding. It is critical. We've seen through Francesco a number of options. I have to say that Qnami used a lot of them, and including some coaching, etc., but also the hardcore funding. You'll have to face, to a certain extent, I find that these grants are not always tailored to the startup objectives because of the delay it introduces, but also because you have some funding for low TRL, some funding for pushing to the finish line, but there's a bit of a gap in between when you have this first prototype and you would like to push to product. Here, there's a bit of a, it's called the death valley in the TRL when you talk about TRLs, but it's also a death valley in the funding. And I think a lot of quantum startups might be in this position. This is changing, though. I think this has been recognized now by the authorities, so it's changing slowly. But in general, grant will be extremely helpful for you. All right, and when raising private funds, talk with people like Quantonation, talk with people that understand what you do, understand where you want to go, but also the type of technology that you're building so that you have this alignment. This also then ties back to my points around partnerships. And the last thing is to create a great team. When you start, I think it's the co-founder team is absolutely key. And I will take our example. I'm so proud that the 4 co-founders are coming from different universities, different background. We might look like another sciencey tech team, co-founder team, but in fact, when we created Qnami, we already knew, okay, we will need someone with really specific expertise on software, on material science, on someone with some drive on the market, but understands all the details of the technology and can really wrap that up. And we picked the people in different places. That's how we assembled this first core unit. And I would oppose that to a team of PhD students that have, you know, something that starts to work, and the four of them start to look like at each other like, okay, let's start a company, who's going to do what, and you take a role by default. The co-founder team is really extremely key because it's the one that have you back in the hard time. They should also bring a very specific value that you can rely on and they can develop over time. Otherwise, you end up in questions like, are all of us needed on board right now? Advisors are key. I think here, Francesco already mentioned that there are options. You should build your own, and you should onboard people that know things that you don't. For us, the hiring of a seasoned executive from the pharma industry was absolutely a game changer in our history. It really drove a fundamental change in our operations, but it was not something natural when you think of it in the first place. Generally speaking, this is not a concern for you right now and when you think of starting the company, but I think that recruiting talents in quantum is going to be one of the struggle in the coming decade for all the companies going there, because it's a lot of companies, it's a lot of work to do, and it's not so many people still. And finally, I think culture is so underestimated, so underrated, so under-talked. So I want to talk about it for a minute. I think the culture of the company and what you really want to do beyond, you know, your technology, what dream do you pursue, is really going to be a key element which will allow you to gather the people around your project. For us at Qnami, one of these goals is to also experience make an experiment with our startup. What can be a different place of work, where hierarchy is different, where the working style is different, focusing on what we need to deliver rather than on you know, a certain authority and reporting lines. So I think this is a key driver for us, and it's allowed us to gather a very specific and unique people around us in our project. So I'll leave it there. If you have an idea, test it. If you have a concept, go for it. I think the journey is really worth the time. You're going to learn about business in a way which is not possible. Otherwise, you will not find that in any books. And if you want to put your energy in a startup, but you don't have your own idea, join a startup. I think it's also a really a rewarding experience, and you could actually join us. We have positions available already now. We'll have more positions available next year, but yeah, enjoy the startup groove in whatever form. Thank you for your attention.
Thank you very much, Mathieu. And thank you very much for your view and your perspective, for your story of Qnami. And I very much like your concluding remarks with "go for it." That's really a very motivating push. Yes, thank you. So, to continue our session, we now want to switch gears and look at the process of building up a company from a very different perspective. So I'm very happy to welcome Olivier to share with us his view, so his perspective from the investor side onto investing in quantum technologies. Olivier?
Yeah,
Please.
so hi everyone. I hope that you can all see the presentation nicely. If it's
yes,
not
this is
okay, fine.
This is very nice, perfect.
Excellent. So maybe I will start by introducing myself. So I'm Olivier Tonneau. I'm a partner at Quantonation. Quantonation is an early stage investment fund dedicated to quantum technologies and deep physics. So as you can see on the slide, we are, in terms of number of investment made in quantum, we are the #1 fund in the world with 14 investments in 6 countries, North America, Europe, UK, Switzerland, And we've also been looking at some other countries like Singapore, Australia, or Israel. We have raised 32 million euros so far to invest in our companies, and so we are still raising, and so we are targeting closing by the end of the year at 60 plus million. Now, with those 14 companies in which we have invested, we've come to account for more than 100 PhDs or postdoc in physics in our companies. Like Mathieu said, if any of you is interested, would be glad to discuss and maybe see if there is some fit with some of our portfolio companies. Before going further, I will also thank Mathieu for the kind words, and I would say in return that we really like very much working with him and enjoy what he's doing at Qnami, one of the very good success of our portfolio. So in terms of quantum, what we invest in, so we invest in all segments of quantum, from quantum computing, and we invest both in hardware and in software. Here you can see the companies where we have invested. We also invest in quantum networks or quantum communications with a few companies there, post-quantum crypto as well. And a few more to come in the coming months. And we also invest in quantum sensing. Here you can see Qnami out of Switzerland and Focus from Canada. Lighton is a French startup and developing an AI chip. That's they call it an optical processor. So we are using the light in order to accelerate some computation for machine learning. So that's the space we are investing in. And in terms of maturity stage, we're investing anywhere from pre-seed. So we can work with researchers and professors to help them set up and create a company, spin off the company from the lab. So we are in general the first shareholder along with those founders. We also invest in seed rounds and then up to Series A or Series B. The idea is that we invest 20% of our ticket for our first investment, and then we try to follow on for several rounds to accompany and support the team. In terms of amount, we invest anywhere from 150K to several million. The first ticket is very often from, let's say, typically 200,000 euro to 750. And then for the follow-on round, we can invest up to several million in each round. Just to give you a flavor of who are our investors, so that they enable us to invest in the company afterward. So it's quite evenly spread between large corporate, people who think that their company or their business are going to be impacted by the quantum technologies. And that's the case for Thales in aerospace and defense. And that's also the case for large insurance or banking companies. And we also have a telecommunication corporate that has invested in the fund. We have a few pure finance investors, so funds of funds that believe that this sector is going to be the next revolution, technological revolution, and so they bet on finding new unicorns or nice companies in this sector. We also have a few family offices, individuals, and Quantonation SAS was a vehicle that we put up at the beginning, that we set up to do our first investment. It was some kind of trying to demonstrate what we wanted to do at an early stage. It was 3 years ago when we were some of the first pioneers in investing in this sector. So we set up this company with a few investors and started to do our first investment, and now they are part of our fund as well. Just to give you a bit of context in terms of dynamics for financing. So what we've seen is strong dynamics, both in terms of public financing and also in terms of private investments. The market is expected to grow very fast and to reach sizable amounts, up to almost 700 billion in 2027, with an average growth rate of 30%, so quite sizable segments. And so I guess that's also why it's attracting private investment. If you look at public financing, there are some large plans that have been announced almost everywhere in the world. So it seems like a lot of money, but you have to keep in mind also that these plans are spread on several years. If I take, for example, the French plan, which is 1.8 billion euro, this plan is for the next 5 years. So that's roughly 400K per year in the 400 million per year in the coming years. But interesting to see that the states and consider that this technology is worth investing a lot of money, and so this will reflect when we speak about potential collaboration, potential grants, non-dilutive financing. This is also as a result of all this sovereign money pouring into the quantum industry. Now, if you look at investment from the private sector, well, there has been a big acceleration in the last 3 years, or even in the last 2 years, this year and the year before. And we have now reached at the middle of the year in 2021 a record in terms of investment in the quantum sector, with almost 1 billion, and I believe up to date it's even more. We are we will near the 2 billion invested by private money in the sector by the end of the year. The reason is being several very large deals, mainly in the US, with the IonQ SPAC, which in itself was already a $650 billion operation. So just in one deal, you had the amount invested in the whole industry last year. So things are accelerating, and we all know that developing hardware is going to take money, it's going to take time as well, but it's going to be quite costly. Anytime you speak of hardware, you need to raise a lot of funds. So I believe this also reflects in this figure. But all in all, more and more funding available for startups, also for large corporates, on those quantum topics. Maybe, well, I see Mathieu had something a bit similar. I just wanted to give a flavor of, when you are a startup, what are the sources of financing? But you have to be aware that there are some pitfalls coming with those financing. So four ways to finance when you are a quantum startup. First one is private equity. And as I've just illustrated, there's a growing interest of VC for quantum technologies, and this interest goes from seed stage to really large series. We've seen some very large series even in Europe, but mostly in North America. So lot of financing available. Some generalist deep tech fund that are very interested into looking into that theme of investment. So I mean, we've not seen a lot of companies do not struggle too much to raise funds. Now, on the other hand, the pitfall as well. We could speak about a hype curve. We've seen some deals where a lot of money has been raised on very high valuation, and well, it's not always coherent with the needs of the company. So what we really look at when we finance a company is that the amounts that are raised need to be coherent with the technological roadmap. As Mathieu said, you should avoid too much dilution too soon, and therefore that means being sparse with the resource, and having the resource you need to deliver your product and your roadmap. But if you don't need more, there's no need to raise more. So the second source would be grants and non-dilutive funding. There are lots of national and European schemes. One of the pros is that it really helps build the IP portfolio. And also at times you can leverage very much private investments and avoid the dilution. There are some companies in which we have invested a first ticket of 250K and that enabled the company to raise $1 million or even almost $1.5 million in non-dilutive funding, which is good, both for the founders and of course for the investors. Now, as Mathieu pointed out earlier, there's a risk of defocus because if you start chasing grants or non-dilutive funding, it could be detrimental to your roadmap because you will develop technologies or bricks of technologies that are not necessarily at the core of your technology. So when doing so, interesting on the financial aspect, but there's also a slight risk of defocus. Of course, you should aim at collaboration or proof of concept. Now also there are some direct collaboration, there are some consortiums, and some of them are very interesting at the European level, for example, and well, they're able to develop very interesting projects. And also one can recognize that an early involvement with the client will help the startups tailor their product to the client needs, and it's also something that we like to see in the company. Now, beware, because some of those proof of concept can be very time consuming. It can also defocus, and one thing that we've seen is, for example, in the software company, it tends to translate into consulting work when you just would prefer to develop your product and sell licenses rather than consulting. But anyway, it can be a good way to engage with clients and to refine your products. And then the last part, of course, which you shouldn't neglect, is direct orders from clients, either public or private. We've seen a few companies that have been able to sell some products. Qnami is one of them. And frankly, it's the healthiest way to get the money in. And even sometimes, because we know that in this space, product will take quite some time to develop, but there can be some interesting tenders that you win and that you need to deliver your product in maybe 18 to 24 months. So you still have time to deliver. Does not have to be a direct sale just for the next month. Yeah, that's something that you need to work out in advance with your potential clients, but a good way to finance your company as well. Now, the pitfall for that is, of course, once you're starting to deliver, you need the capacity to scale, and you need to be able to monitor the quality because you'll be delivering to an industrial, and if he has to integrate your product into his process, it has to meet some quality standards, and sometimes it can be a bit difficult to achieve for a startup. Maybe just to give a broad view of the criteria, the key criteria that we use when we look at an investment. So there are mainly 4 things in which we are interested when we look at a new company or new project. The first one is technology. Well, quantum is very specific segments, so we want to make sure that the tech is world-class, and that when we invest in a company, it is one of the 2 or 3 leading teams on this technology. We want to make sure that the company has IP rights. We want to make sure that they have proximity with the labs where they come from, and most often in the early years or early months, they will still need access to equipment, clean rooms, labs, etc. And of course, we want to have a clear vision of roadmap. We know that the technology is not ready and not up to date yet, but we want to make sure that the founders have a clear vision of how to get there and how to deliver their first product, what it will look like, and what are the bricks that needs to be integrated and fabricated before you manage to get that product to your client. So second criteria would be the team. We want an outstanding team, a team with who has done publications, who has some references. As Mathieu said, we want people who really have passion for what they are doing, that are ambitious and really not shy, do not shy away from creating a company. and going for it, as Mathieu said earlier. Third criteria is, well, maybe if we found a very nice technology and a very nice team, we want to make sure that the transaction is reasonable, because if we find the best technology in the world with the best team, but that we pay too expensive, and of course, or that we can never sell our share, then of course for a VC, there's no way for us to make money, and we cannot give back that money to our investors. So we need to make sure that the amount raised are sound and they are in phase with the development of the technology, just the right amount of money, not too much, because then it's too dilutive for everyone, or the valuation is pushed too much up, and not enough, because otherwise you don't have the means to develop your technology. So need to have also key terms of governance, and be able to sell your story, because if we invest now, VC will want to see what's the story that you're going to tell to the next investor in 2 or 3 years, or at the time that he will need to exit his investment. So that's also something that needs to be worked out upfront. And then fourth one, I would say fourth important one would be to demonstrate that there is an early traction, that there is a market, and at least that the company knows the product and to which end they will manufacture that product, which type of market, which type of client. We know that at this point we will not have a clear and detailed business plan, but we just want to make sure that the company has in focus what they want to reach in terms of value proposition, type of product, and so on. And that's about it for the slides. So I guess that we will be entering some Q&As just after that. So I'm totally available for that. Thank you for your attention.
Thank you very much, Olivier. Thank you for your very detailed view on detailed overview over especially your key criteria that you mentioned towards the end as a guideline, also to motivate to just go for it, as Mathieu had mentioned earlier. And yes, you're fully correct. So now we would like to continue with our Q&A part of the session, where I'm very happy to spark a vivid discussion between all of you, and very much based, of course, on the questions that we get from our audience. So please feel free to continue to submit questions such that we can pick them up here in our Q&A session. So I want to maybe start with a very general question first, to basically now, yes, which I would be happy to address all of you. So to basically contrast now what we have learned today about how to build a startup, to actually already how one can position oneself as a startup compared to the big players in quantum technology. And for example, in quantum computing, here, of course, the big computing companies such as Google, Microsoft, or Amazon come into mind. And so I would be very curious here about yes, how you would judge this interplay, and how one can position oneself as a startup here. So are these really seen as competition, or more as an enabler? And also, if you expect any change of this relationship. So maybe I would be happy to start with Olivier. So
yeah, sure. So of course it's a question that we get asked very often, because when we invest in a quantum computing company with a technology that's different from Google, we have everyone coming to us saying, wow, how are you going to be able to compete against those guys? Well, first, the one thing I believe that's important to understand is that all the qubits are not the same, and there are different competing technologies, but they do not have the same property, they do not have the same coherence time, they do not have the same capacity to scale, they do not have the same rate of error. And so I believe that we are in a phase where until you reach a fault-tolerant computer, and that may be in 10 or 15 years time, until then, all technologies will have their own application and their own use case. There are some computation that you will be able to run on supraconducting qubits, and other that will be better on atoms or on ions. So we believe that we are not at a stage where winner takes it all, first. And second, when you look at the large corporates and their investment, they started investing in that field 10 to 15 years ago, and they've made heavy investment to develop a technology that was available at the time. Now that they've made this decision, they need to support that technology, but that does not mean that research stops. And there are some other ways to produce qubits that have emerged ever since, and that may prove to be interesting. So, I mean, just make the proof that it can be the case, develop the technology, and maybe someday you will have a Google knocking at the door saying, well, I think your technology is worth of interest for me. We discussed that with, maybe I will hand it to Mathieu, because we discussed that as well. NV centers, which Mathieu is working on for sensing, could also be used to develop quantum computers. It's a long-term play, but it could happen. So, I mean, I believe that the game is not closed. There are opportunities for new technologies, and you know, the large players are already, I say, becoming large corporates, so they are less agile than the startup and research centers. So I believe that there are still some nice things to be done and to compete very efficiently against those large guys.
Yeah, I just wanted to add one comment to that. Like, big companies can, there are also cases, I mean, the case of Google developing their own solution is one where it sounds like a direct competition. But first, it's a big ecosystem to develop. So there's plenty of different areas to focus on. And lots of the startups which I meet don't have as a final goal to propose a fully fledged quantum computer, but maybe to develop a specific part of it or a component or a software. So that's one way to think about it. And something different, it's also like you have a lot of these very big companies that sense the importance of the topic, but don't want to invest their own time and resource and people. So that is the case, for example, in the partnership we've secured with a large equipment manufacturer. They want to understand quantum, they want to be part of quantum, but they didn't want to do it themselves. So the partnership that we have with them allows them to get access to that technology in a certain way. But it doesn't take anything away from us. Actually, it's one of these, a place where you can have a win-win between two very different companies, I think.
I'm not the specialist in the room, so I'm not. I will not dare have a comment. Just maybe if you look back in the history and the development of technology, it's always very interesting to see what the big players in the room, how they get kicked out because of a small player coming with another approach. And yeah, and I think in quantum, it's going to be quite fascinating to see who is going to survive on the long term, and where the big breakthrough are going to come from. And this is not necessarily from those which have the big pockets.
That's true. There's, I'm sure there's still a lot to explore. We're also, yes, also as a tiny company, one has lots of possibilities. But maybe to hook onto this competition idea to big companies. So now we have mostly looked at this technological side, but you also mentioned how important it is to have a expert team in the company. And so I could see also here that there might be some competition regarding on the building a team on the hiring side, and especially now with quantum technologies, with the market growing quickly, we are to expect a lack of expertise, a lack of expert people in this field. So did you experience here any competition in this direction with big players, or do you see this as a potential danger, as a potential difficulty?
Maybe I can give a first part to that answer. I think the problem is not so much in terms of a competition between small and big players. It's just a competition in the market. I think it's fair to say that there will be a shortage of quantum scientists to fill all the positions that could be available. The way out of there, the way I see it is like, there are in your company a number of key roles where knowledge of quantum is necessary, but the position of those people should be to be able to link that with other positions. For example, when you develop a quantum computer, there's a lot of knowledge needed around microwaves, and these are like competencies which exist already. The only question will be, how do you manage those projects, and how do you have those people working together? So you will need a few key positions. I think it's great for the people now just coming out of a quantum, physics study, exploring opportunities in the market now, or thinking about doing some first business course, etc., to kind of connect all these different pieces together.
Maybe what I would like to add maybe is that it's not only in terms of quantum skills that there's going to be a shortage, but there's also a shortage in much more classical jobs. I think most companies have difficulties to find people, good engineers working for software developments or for control electronics. So it's, of course, there's going to be a battle for talents in the quantum space, but bear in mind that it's also the case for a lot of other positions.
Yeah.
I can just add here, so maybe two elements. One is this is a concern at the European level. They're trying to have curricula across Europe because they see that there is a shortage on skills. And the second element is also there are on the funding side. So if you take funding schemes with Marie Curie, they do have some transition, so some schemes which helps researchers to go out from the lab and to have this transition toward the industry, and to make internship in companies, to get used to this private sector world.
Maybe to come back to Francesco, what you just mentioned, back to these opportunities. So also also regarding the funding programs that you had mentioned earlier. So opportunities for people, for researchers, and also young entrepreneurs. So for the programs that you mentioned, are there restrictions regarding nationality or residence? Since you specifically mentioned Swiss programs, so to whom would these programs be open?
So the Swiss programs are not restricted in terms of nationality of the grantee or the applicants. It's the entity which is irrelevant. So as long as you are in Switzerland with working permit, and some of the programs you don't even need to be incorporated yet. But as long as you're in Switzerland and you have a valid working permit in Switzerland, then you can apply for those ones. And actually, a lot. I think the team of Mathieu is a nice example of mix of nationalities. So it's really you pull people from all over Europe or all over the world, where just the skills which count.
Perfect. Thank you. So we also have a more technical question in between. So Mathieu, this would be addressed to your microscope system. So would you like to compare it maybe to other technologies? So for example, to AFMs and to yes, how these technologies compare, and what the advantages are of your system compared to these.
Sure, I can do a bit of a promotion here. I actually just answered. I thought it would be too technical, but in short, quantum technology, or the type of metrology we do, is already superior to classical technology. That was the question in the chat. So the person mentioned that you can already measure details with existing classical solutions which are below the nanometer. That's true when you look at the topography, when you look at the landscape of the sample. Here we're really talking about the resolution in providing information such as shortcuts or specific magnetic textures from a memory. So read the information that are called functional imaging, and there the resolution is typically, you know, maybe a bit better than a micron, but definitely not in the range of nanometers as we propose. So that's the technical value proposition.
Perfect, thanks a lot. Yes, so then to maybe go back to the more entrepreneurial aspects. So we had mentioned earlier that there's this competition, and that this of course also can be a danger. And so of course, so what's a big risk for startups is the potential to fail. And so here, from your perspective, so what are the chances for success, phrased like this? So what is the percentage of quantum startups failing in these high technology sectors? And also how can we best perceive this? So so we don't really have a positive failing culture, as is a bit different, potentially also in the US. In Switzerland, it's not as positive. And so do you see that here we, to which extent can we embrace this danger? And do you see that there would be that we would need a change in our perspective to boost quantum technologies in Switzerland further? So maybe I would like to address Olivier first for this question.
Yeah, so maybe first to answer, is there a specific rate of failure for quantum startups? Well, it's difficult to say right now, because most of the companies that we have today have been created in the last 2 or 3 years, so it's still a bit early to say. Now, if you refer to deep tech stats, the rate of failure is around 40%. For startups, so it's pretty high. Then you will typically have about half of the companies, so about 50%, that well, are almost worse or a bit more than what the money that has been invested in the company. And then you can take 10% that you can consider as a success. That's the ratio that you can have. So it's quite a high rate of failure. I don't think it will be very different in quantum. Now, there has been a lot of interest for quantum, so companies have been well financed so far. So we'll see what happens in the coming year. And there's always, you know, when you have a hype curve, there's always a lot of money pouring. Then there's going to be a much more difficult part in the next 2 or 3 years if the technology does not deliver up to what we expect before it gets better. We've seen that in lots of technological revolution. But that's for the figures.
Mathieu, would you be sharing this view, maybe from your perspective? So how did you experience it, especially in the early days of your company? So how much was this a concern, or how much was this a motivation?
Yeah, so it's my first startup. Maybe that's what I should mention here. So I don't have the experience of failing before and talking with investors that failure on board. I know for a fact that in Europe, we're a bit more sensitive around that. I also feel like it's changing. Maybe it's a generation thing. You should ask Olivier, but in a sense, I'm pretty sure that if you have a good reason for having failed, it can be understood, right? So I don't think it should be so much of a problem. And that's what I try to think when it comes to, like, when I think of me failing, that's how I try and think about it, right? What you don't want is to make a gross mistake. But there is also, you should acknowledge that you cannot control everything. So that's how I see it from my perspective.
Thank you. Perfect. So our next question would be, again, going direction of funding. And you had very extensively presented these different types of funding. But so one aspect where one could also have in the back of one's mind is, yes, even especially at the start for a tiny company, so very early funding in the form of, yes, personal connections like friends, families, or also crowdfunding platforms, yes, which also seem to be more and more popular for many different projects. So would you see this as a viable option for starting a company, or would you see that the budgets that are actually necessary would differ too much in this regard?
I think it's a good idea. I mean, when we invest in a company, we want the founders to have some skin in the game. We want them to have taken some risk as well, and not only start the company with taking the risk with someone else's money. So involving friends or family is a good way for us to make sure that they will want to deliver as well. That's a first one, and frankly, I prefer that to having a crowdfunding platform where it's more impersonal. But then you have to manage the drawbacks. That means that when you come to the later stages of financing, Series A or Series B, I mean, if you have 30 people that you need to call every time that you need to make a decision, it can become quite complex. So it's good to involve friends and family early on to get a bit of funding, and maybe that will help you get some more dilutive funding that gets the company going for a year or a year and a half until they are ready to raise some more fund along with professional investors. But you have to make sure that it will be manageable and reasonable in terms of governance. And crowdfunding is a bit of a, I mean, it means a lot of different things. You have some platforms, well, co-investors of us in Qnami, platforms like Verve Venture, and they are able to represent all their investors, and they invest tickets of $1 million and more. Can also be small tickets of a lot of independent persons. So also, I mean, there are some very different things behind that word. But yes, of course, I think it's a good solution for early financing of the company.
Francesco, would you also like to pick up on this? How this compares to yes, to the networks that you introduced, and to which extent this aspect might also be important to weave into here?
Well, for us, the kind of funding we deal with, this is a bit transparent for us. So I mean, we deal mostly with either support. So Euresearch itself deals with European funding, and there they don't care much where you get the other funding from. So these are, most of it are in form of grants. You had in the past for some equity, so this EIC accelerator. But this is a bit neutral from that respect. So there is no, yeah, I think what is striking is the variety of paths to have the company starting up. And I think I remember the same session we did it back 2 years ago. And there we had Sadik, so the CEO of Zurich Instrument. He was quite striking when he was telling his story, how Zurich Instrument started. It was a complete unconventional way of starting a company. And I find it is a bit what Mathieu said before. It's on one side, you would like to have stories, but there is no guarantee that these stories are your stories. So you have to find your own way because you have your own specificities. And yeah, so find your path and talk to the people and don't be afraid to fail. I mean, failure is, you don't learn to cycle if you don't fall a couple of times.
Perfect, thank you. So yes, regarding maybe the timeline of funding, since Olivier also mentioned early funding. So you had this this very clear overview over your key criteria or the key aspects, this list. And so yes, so how can one best go about it? So which of these criteria are the most critical to address for which type of funding maybe? So is it already critical to have the product in mind or developed to some extent and then go for the funding? Or how critical is it to first have the team and then, yes, how this compares?
Yeah, for us, it will be more technology and team. And we know that if you have both, then you will end up with a product. But really at this stage, we know that those technologies take time to develop. And we know, I mean, the game is taking an experienced lab that's taking a full room and that has cable everywhere to making it something you can put in a rack or something that your client like Mathieu can use every day by pushing on 2 or 3 buttons. And we know that this does not come overnight, but if you have the right technology and the right team in place, then it will come at some point.
That's also my experience, that idea first, you needed to get started, then team, because you needed to present your project, right? If you go alone and try and raise money without a team, it's very difficult, not only on the personal side, but also to convince an investor. I think showing a team is really key, right? It already shows that you know how to go about the first steps. So yes, that order, and then the product.
Maybe I can add one word on this. Has nothing to do with what Olivier and Mathieu were talking about, but just if you look at the different grants that you have, I think one element you have to consider is you have to understand what's the goal of the grant itself. So the commissions, at least the grants I've seen on the European Commission, they have a very specific scope, and it's important to understand the scope of these specific grants. You don't address an EIC accelerator the same way you address an EIC Pathfinder or an EIC transition. And if you go for Swiss grants, then they also have a different flavor. So but there are plenty of people around there to help you understand that, check your idea, and to help you find to shape the project and to use the right tool, the right grants for the right goals you want to achieve.
So maybe regarding the setup of the team. So also coming back to the point we raised earlier about potential difficulties in finding experts. So how does it compare to have early hires to basically grow the core team quickly with experts to cover these areas in the for development compared to outsourcing these tasks? So basically hiring companies and not having the experts in-house, but having collaborations.
Yeah, maybe I can say a word about it. My way or the way we do it in Qnami is like, if the work is really IP critical, I think you should think twice before outsourcing the work, because contracts are gonna take you there, but it's always more difficult to control than the work that you do in-house. So I think IP is really key when you think about what you want to do in-house and what you want to do outsourced or with partners. So I'd say this is one thing. And the second thing is really the value add, right? Where can you do something that other companies cannot do already or easily? And that also should be the core aspects that you focus on in your company, right? Because this is really the value you're creating when you build your startup. If you need certain periphery equipment around it, it's going to be a good question whether you should redevelop it or actually just buy what already exists. And when you think of what value do I create for my company, what will, you know, if I do another cryostat or if I do another atomic force microscope, what good does that do for the company versus just buying one that exists already? If you find out that you can optimize costs by like crazy, maybe it does good for you, but it's still a good question to ask yourself. It's not always clear. And then you should buy out.
Perfect. Yes, maybe a bit of a more intricate question regarding the assessment of the value of a technology or of a startup. So since since these disrupting technologies are of course by nature something very new and explored. So Olivier, so what are your best assessment methods to just find out which technology actually has the most potential?
Well, first, I have to mention that in the team we have two quantum physics PhD. They are the first one to look at the technology and to evaluate it. Second thing is that we spend our time looking at scientific publications. So we are more or less, when we speak about one technology, know what the state of the art is. Third, as I mentioned in our presentation, we have more than 100 quantum physics PhD in the portfolio company in which we have invested. So it enables us to get some advice, get challenge the companies or the startups that we see. And then one other thing is that we also rely on 30 to 40 scientists all over the world in some labs that we can call for due diligences on specific technologies. So, and the last thing, we have the luxury in this segment, quantum technology, that everybody is starting companies at the same time, more or less. So we have the luxury of when we see a technology, we see the 3 or 4 teams that are working simultaneously at the same time on this, and we are able to compare, which is very different from what you can see in other investment segments, and which has a lot of value for us. Now, I would say, so it's not that complicated to compare between teams and between quantum technology. Now, the difficulty is to compare quantum versus classical. And this is especially true in sensing because some detectors, some sensors are very powerful as of today, and quantum detectors are not always up to this level. So we have to see whether when you develop the roadmap and when you develop the product, the accuracy, the speed for detection, precision, then whether you have a chance in the next 4 to 5 years to be up to speed compared to classical sensors. It's a bit the same with software. People are working on quantum software, but they don't have yet the computers to run the soft on it. So we have to understand whether and at what point, when the machines are available, if there will be some quantum advantage or not. So not so much, the difficulty is not so much in comparing the quantum technologies between themselves, but more comparing versus classical technologies and seeing the timeline. I mean, it's broad, of course. So we are speaking 3 to 4 years, 5 to 7 years, in which the quantum technology will become relevant versus their classical competitors. Bearing in mind that, of course, the classical competitors are also making progress and improving. So you have to factor that into the equation as well.
maybe from the other perspective, to flip this around, Mathieu. So what would you say are your key criteria to actually yes, sell the technology and be convincing with respect to to also the classical competition, of course?
So do you mean how do we evaluate our competition, or do you mean how we evaluate ourselves? I'm not sure if I'd like to answer the right question.
I would say so. Both of these, I would assume, play a very important role. So yes, basically how to present this new technology, and how important it is to also compare it to the already existing technology to convince investors of the value.
Yeah. I think then so I think the conclusion after trying lots of different stuff and talking with hundreds of VCs is like best is to talk to the right ones. So the value proposition that we have is pretty technical. The markets we're running after are pretty specific. So there is no way you find the right twist for all the investors. It's just not working. Every time we have a VC meeting, we end up with another suggestion how should thing or could thing be presented. So there's just no way to get about it in one single way. So you have to find the way which is effective for you. And the one which is effective for you is actually the one which focuses on the markets that you want to achieve, the people that you want to talk to there, what makes the business work. And then these investors are around that segment, around that market. And then the value proposition can be, I think when we discussed with Quantonation, it was pretty technical, right? Like this is the type of product we want to do. This is the type of profile, the customer we're talking about. It was very specific, and it really helped to have an investor knowing what we were talking about. For us, it remains an extremely complicated sale for a very large Sequoia type of VC, despite the quantum buzz. Maybe you get the first talk, but then it's still complicated because it's not their prime business.
And by the way, what I forgot to mention is that when you do our due diligence on technology or products, we try to speak to clients or prospective clients. We try to understand which technology they use today. What are the specs for this technology? What are the specs that they expect in 4 to 5 years' time? And do we believe that quantum is going to be able to catch up with this? Because there's no way you're going to use the quantum if it's not more efficient than classical. So understanding really the use cases and what the client expect in terms of reliability, precision, speed, that's very important to assess the technologies.
Perfect, thank you. So yes, I would maybe before we close, like to wrap up our Q&A session with one more question to the full round. Basically, taking a bit of step back, a view onto the market as a whole. And you had mentioned this astonishing growth rates in the market of quantum technologies currently, with around 30%. And also this very strong dynamics in this market. And yes, I would like to maybe ask for so to which extent do you see a flip side also in this? So so to which extent are there risks in this strong growing market? So which sort of dangers do you see? And maybe also like comparing it to previous technology bubbles so how to assess the market to make sure to not buy into a problematic strategy. And maybe yes, so just generally, so how do you see here a difficulty as a market as a whole, but also, of course, for the individual startup? So what risks does this growth rate bring, and what advantages does it bring? So how to exploit this growth rate best? So I'm not sure. Maybe Francesco, if you would like to start from your point of view.
The only one which has, or the only two which can have an educated guess are Olivier and Mathieu. I'm certainly not. I'm the last in the room. No, I mean, indeed, when you see such growth rates, it's a bit frightening, I must say, and it's not very safe. But on the other hand, yeah, you need to try. And indeed, I mean, from an outside perspective, because again, I'm not the specialist in the field, and there is always on all these hypes around blockchain, around AI, around all these things, you have quite a thick layer of hype. And the question is how much of this layer you should remove to really come to the bottom and what would survive. And the other thing is, we have seen from machine learning that you have these, these machine learning winters with periods where the hype is over, but you still have people working on that, and then comes the next wave of breakthroughs, and then you kick off another hype. So yeah, I honestly, I don't know. There was something will certainly survive, because the mindset, I mean, the basics behind that is it's not fake. I mean, there is a big, deep change in the way on the technology in the background. So it's not just a kind of surface thing. Now the question is, again, the big question, and this is what is fascinating in all this big range between computing, communication, sensing, and cryptography, who is going to benefit at the end and will remain out of these big investments we are currently experiencing. But I couldn't say. Yeah, very difficult question.
Olivier, would you maybe have a perspective on this?
I'm quite aligned with Francesco. I believe that quantum is nothing short of a new revolution, but also that we are in for the long haul. It's a very long term. Technologies will take time to develop. They will take time to reach industry and to be implemented at large scale. So one has to understand that before investing in those technologies. Our fund is a 10 years fund. So we know that we are going to be an investor and to support our companies for a long time. Now, there may be some disappointment for people who invest just out of hype and that expect to get some return in the next 3 to 4 years. I believe this will not happen. But still, I mean, I'm pretty sure there will be some disappointment in 2 to 3 years, but I'm pretty sure that there are some great companies in the making, and they will change the way that we conduct business in a lot of sectors in the years to come.
Yeah, I also fully align with these comments. If there is a bubble, it's only financial. It's only around the timing, right? The question whether quantum will come or not is not even a question, right? It will come. It's physics which is around us. It will be a technology. It already starts to be. So it's just a question of timing. I'd say there is a huge bubble, maybe, but I'd like to remind that the types of bubbles that we see in biotech and that we see in other AI, there are much more investment in other segments. So quantum remains very small compared to all of that. And last, for the entrepreneurs that feel this is a risk, I don't think you should think about it too much, but I also see this space as it's like space exploration, right? You have all these technology that you need to build up to achieve the final goal, which is to send a rocket somewhere. But all these technology, they kind of then find applications in a range of markets. And I think the same is going to happen with quantum when I see people developing microwaves, cryostats and stuff. And we already know they are needed in other markets than quantum computer. So I think opportunities will just come naturally.
Thank you so much for this positive perspective. I really like this view, and I think this is also a very motivating statement to conclude our session today. to grasp the opportunities. So yes, with this, I would like to thank our speakers, Francesco, Mathieu, and Olivier. Thank you so much for your presentations and the lively discussion. And of course, I would like to thank all of you for the active participation and for the for asking this very interesting questions and inspiring us in this conversation, this discussion. And yes, with this, I would like to conclude our session today and give an outlook onto next year's Quantum Industry Day in Switzerland, which will happen on the 4th of October in 2022. So save the date for the next Quantum Industry Day. And thank you so much.
And thank you, Michele, for moderating the panel. Very, very appreciated.
Thank you.
Thank you very much, Michele.
Bye-bye.
See you next year.
Bye, everyone.